the group here around Caroline Lange, Trami Ho, Lars Witte, etc., and Stefan Olamek, who might be ringing a bell for most of you, they have studied these options for nanoscale landers for the Martian moons. And the baseline here, this looks a little bit different, but the baseline here is that we are orienting on mascot landers basically, and that we have some constraints here. We are counting on a maximum of 3 to 4 instruments with a mass of maximum 3 kilograms. And a total mass of a mascot-like lander for Phobos or Deimos to weigh about 15 kilograms. We have of course, some features here. We have power that can be either a battery solely battery powered, or solar panels are also in design. There's communication between the lander and the spacecraft, and so on. The attitude control would be very passive, so we wouldn't really know how we land, but uprightening as on mascot is in discussion, and so on. So also the interfaces based on these small landers are very well set with a compartment that can actually be then applied to have thermal control during cruise, but and so save resources for the lander. Also loading up the battery during cruise stage to have a full battery when landing is also an option here. So what are the principal strategies if you look at Phobos from a science case, basically? That has been already mentioned by Masaki, that we look at the long-lived package or a mobile package to actually add value, scientific value, to a mission like Mars Moon's Explorer. And for the long-lived option, we would suggest to obtain clues on the origin of Phobos and Deimos by actually constraining the interior structure, basically looking at the rotational parameters, at their properties of the surface. So when you land, for instance, get physical, electrical, elastic properties of the surface. Also locally understand the compositional parameters, which would also be the case for the sample, of course, but this would be a different place then, of course, and but also understand the space weathering effect or whatever actually contributes to space weathering on the surface. So to do so, we identified a few instruments here, a zenith camera to look at the stars, to actually determine the rotation, very detailed radio science experiment, also for the rotation and location of the package on the surface, seismic or accelerometer instruments for actually getting the elastic properties. Also, the chances of possibly recording a micrometeorite impact are apparently not too bad, depending on the time scale you're looking at here. And a very long-lived feature would be a retroreflector. So this could be a feature that is also useful for future missions, even once this mission has left the Martian moon system. The other option would be a mobile option, and here we come into the topic of having a mechanical device inside the shoe-sized box of mascot, for instance, to actually have that spun and then released to hop a little bit further, whereas the hopping is uncontrolled. And this would allow us to actually determine the composition of the surface in different places. We also get the physical properties, looking at accelerometers again, seeing how deep or how much damping there is when you land again. And again here the understanding of Phobos soil with the space weathering. Here again a small suggested set of instruments and a camera to actually characterize your surroundings wherever you've landed. Ellipse, Raman, there are studies about micro ellipse. So APX, this would actually allow you to characterize the surface based on a geochemistry or mineralogy approach. APX, Mara would be to actually look at the thermal properties of the surface wherever you land, and the primitivity probe for electrical properties of the soil. So this is just example. These are basically example payloads that are under discussion at the moment. But the mobile and the long-lived version, these are the prime suggestions at the moment from our side. We also have put some thought in how to actually deploy such a lander. There's for Phobos, it apparently states quite difficult to just drop off to have a ballistic landing, because the impact velocity is just too high. Current simulations show that we would be touching down with 3 meters per second about. That would be quite a big impact. You also need quite well location system for the main spacecraft to drop the probe off. Another option would be to have the landed package actually basically housed in the prime lander for the sampling return, and then drop it off with some kind of mechanism. I will talk about this in a second. Or another third option would be to have really this would be more the mobile option. Here they put some wheels on that should basically indicate this robotic option, and having a robotic arm on either side, the main spacecraft or this robotic mobile option. So how could such a probe be attached on the spacecraft itself? So this would be here the ballistic option, where you have this is a cut through the housing, where you have a spring here that will be released for separation. On the other side here, that will be the main landed spacecraft, and you would have a lever to drop off the package basically. And that would be a very smooth development of the package. For the ballistic approach, we see different other constraints and difficulties. Here, as already said, the impact velocity would be rather big, and so you would need to care for the protection of the probe. You need to stay, of course, within the escape velocity to not risk a liftoff from the surface again. Downside of this, main downside of this approach would be that you have a random attitude on the surface, so you need some uprightening system, and the spring could just lift you off to drop or to jump to another place. So a more controlled version would be a lander here. There you know very well it's a Philae-like approach. There you know, of course, very well how you land, what's your orientation, etc. But we also estimated that this is only sensible for larger payloads, so 30 to 40 kilograms would be here a marginal number. So anything about in this range, it would make sense to have a 3-leg lander. Anything below this, it's not worth to carry all the infrastructure for landing here. Okay, you would have different option issues too. So you would increase the height over the surface, which might make other operations difficult. So in the end, I think that's the current favorite for a ballistic approach would be to house the land package in crushable shell. Here, the total mass, including crushable shell, would be 30 kilograms. You could also house or place on these blue sides, blue areas here, solar panels that could extend your lifetime, but would make this option here immobile again. Yeah, the power options are also widely discussed with Muscat 1. There's only this primary battery, and okay, if this runs out, that's about it. So you are limited in lifetime. Here, there is a discussion about further developments, including these solar panels, also including the passive carriage on the main spacecraft to have a fully charged battery once you are separated from the main spacecraft. But with the solar panels, you have a very good opportunity to get an extended lifetime for such a landed package. So in conclusion, we have thought about many different options to provide, especially the Martian Moon Explorer with a landed package. So from the scientific point of view, we see options. And from the engineering point of view, we have many building blocks that can be quite freely combined, as it seems. We are basically working on providing a good option for our Japanese colleagues and also using the heritage of Muscat 1. And I think that's the last slide. Yep, sorry. And I'm open to questions, though I have to stress I'm the messenger, and any questions I can maybe forward and get you the correct answer when I get it back. Thank you.
Any questions?
Have you considered the possibility of radiant energy beaming to landers as one of the alternatives?
No, I don't think so. These are the two options I know of. Basically, having a primary battery is kind of a set fact. That's my understanding, at least. And then having a secondary battery that can be charged through solar panels. That's the second option. So.
Maybe some more alternatives that are emerging in the CubeSat world.
Right. Okay. Yeah, but I'm not sure whether ESA or JAXA are so firm in employing CubeSats. So that's an issue, I think. All right. Thank you very much.